There we go. All right, so you get 592 inside here for the discriminant. Notice how I still have the actual square root right there. This is kind of going back to what we talked about when you reviewed our homework. If you take the square root of this number and you get a whole number, that's fantastic. That's what we would ideally want to have happen. Then you would just write that number down and finish solving. But if you take the square root of this number and you get a decimal, then that means we have to take that number and simplify it. So 592, the square root of it's a decimal, so I'm going to go to the side and I'm going to break down 592. 592 is an even number, so 592 divided by 2 is 296, which is also even, so that's 2 times 148, which is also even, so 2 times 74, which is also even, 2 times 37. And you can stop on 37 because that is a prime number. So if I look at this, here's my pair of 2's, which makes a 2. Every pair makes 1. There's a pair of 2's, which makes another 2. And then that 37, since he doesn't have somebody to match up with, is going to stay under the radical. And so that gives me 2 times 2, which is 4 radical 37. So this square root of 592 simplified down to 4 radical 37, which means we're going to replace this right here with 4 radical 37. So we have negative 4 plus or minus 4 radical 37 over 18. So now we're there. And in reality, you're done. You have, or I shouldn't say you're done. You have the correct answer. That is the answer. The only thing that has to be done now is some simplifying. And so when you're simplifying with a radical here, if you go back and you were to look at those homework problems we did a little while ago, we were crossing things out and eliminating. The only time you can cross the numbers out and eliminate them is when you have nothing but multiplication on your fraction. We don't have just multiplication. We have addition and subtraction here, so that's not going to happen. What we want to do now is, my radical 37 is never going to change, but we want to look at these 3 numbers right here. I kind of call it the triangle. And we want to ask ourselves, what goes into negative 4 that also goes into positive 4 that also goes into 18? So what number goes into all of those?
2.
2 does. So I'm going to divide this by 2. And so negative 4 divided by 2 is negative 2. Plus or minus positive 4 divided by 2 is 2. Radical 37. 18 divided by 2 is 9. And so I get x equals negative 2 plus or minus 2 radical 37 over 9. If I wanted the decimal form, I could just type that in and it'll give me the decimal form. How many answers is this right here? How many solutions?
2.
That's 2 again, that's right. Okay, so you're allowed to leave it like that, and I know you're giving me both answers. If you don't like to do that, you can separate it. You could say x equals negative 2 plus 2 radical 37 over 9 and negative 2 minus 2 radical 37 over 9. But you don't have to do that. This right here is an acceptable way for writing your answer. Does that make sense? That's one method, one that we've learned before. We've been dealing with the quadratic formula for 2 years now, but now we just want to make sure that those radicals, that we simplify them and we simplify down as far as we can to get them the perfect answer that we can get. Let's look at another way to solve. Excuse me. Example 2. Solve using square roots. And I'm going to put in parentheses, only works if no b. So if we think about the standard form of a quadratic function, ax squared plus bx plus c. A is always in front of x squared, b is always in front of x, and c is always going to have no variable, which makes it your constant. If I look right here, you can see b is in front of x. I don't have an x. That's my a, and these two guys, when I combine them, would be my c. When you don't have a b, you have the option of solving with square roots. And it's actually much quicker than the quadratic formula, but you have to recognize when you're allowed to do it, to use it. And that would be when you don't have a b. That's not to say, if you wanted to, you could move the 12 over, identify your a, b, and c, and plug it into the quadratic formula. You can always use the quadratic formula. It's just if you do that, your b is going to be 0. It'll still work though. Okay, but we do have an option of square roots whenever we don't have a b. And so when we're using square roots, we want to kind of treat it like it's a linear function, and we want to isolate the variable. So if I'm going to isolate the variable, that means I want to get that x by itself. So I'm going to start by moving the -8 that way. So that's going to give me 3x squared equals 12 plus 8, which is 3x squared 12 plus 8 equals 20. Does anybody know what I would do next to isolate that variable? Very good. Divide by 3. So I'm going to use red. Divide by 3, divide by 3. These are going to cancel, which gives me x squared equals, and then 20 cannot be divided by 3, so that's just going to stay 20/3. And I'm almost there. I don't want x squared, I want x. Does anybody know what I do to get rid of that little 2? Square root it. So now we're going to square root. I'll do it in red. And whatever I do to one side, I do to the other. The square root of x squared is going to be x. And then here's something that might be new for some of y'all, but you're going to have to remember this every time or you'll get it wrong. Anytime you square root, your answer is going to have a plus minus sign in front. So we are going to get plus minus the square root of 20/3. And so that's a lot quicker than what we did before, but we're still not quite done. We have our final answer. We just have to simplify. And so I'm going to go to the side and I'm going to simplify that radical 20/3. So radical 20/3, this is my simplifying, is the same as radical 20 over radical 3. Which, if we remember, we cannot have a radical on the bottom, so that means I'm going to multiply this by radical 3 over radical 3. So on top, radical 20 times radical 3, 20 times 3 is radical 60. Radical 3 times radical 3 is radical 9, which is a perfect square, so that goes right back down to 3. So you just want to start memorizing that anytime you multiply the same radical, you just get that number. So now I'm there, which means I'm closer, but I still have to break down that 60. So I'm going to break that 60 down right here. 2 times 30, 2 times 15, 3 times 5. So that makes 2 times 3 times 5, which 3 times 5 is 15, like that, which means that the radical 60 became 2 radical 15 over 3, like that. And so my final answer is plus or minus 2 radical 15 over 3. Like that. So that's another option. Does that make sense? Okay. I want you to try this one on your own. I'm going to give you about 5 minutes. Let's say that we have negative x squared over 5 plus 15 equals 0. Notice that we have no b. So try to solve it with square roots, and we'll go over it in about 4 or 5 minutes. So give that a shot. All right, so hopefully you had a chance to try that. You know, there's a couple ways we can solve this one. The first thing, like I said, you want to notice is you have no b, so square roots is a way to go. If you wanted to use the quadratic formula, it's a little more challenging. Your a would actually be negative 1/5. Your b would be 0, and your c would be 15. But I'm going to use square roots. So first thing I like to do is I have a fraction, so I'm going to get rid of that fraction by multiplying by 5, which is that denominator. So that 5 is going to basically eliminate that 5 right there and give me negative x squared. 5 times 15 is 75, and 5 times 0 is still 0. You didn't have to go this route, but that's one thing you can remember is we can always get rid of fractions to make our question easier. I'm going to bring the 75 over because now I'm just isolating the variable. So that's negative x squared equals negative 75. And then I have a negative 1 there, so you're just dividing by negative 1 on both sides, which gives me x squared equals positive 75. Last thing I want to do is get rid of that little 2, so I square root, and then most important, we just said it, anytime you square root, you get plus or minus the square root of 75. So you actually have your answer, you just have to simplify it now. So I'm going to go to the side, I'm going to break down 75, it's 3 times 25, 5 times 5. That pair gives me a 5, radical 3, so I know x is plus or minus 5 radical 3. Hope you got that one right. Did I get that one right? Good. So that's the second method. Quadratic formula works all the time. Square roots work when we don't have b. Let's look at a third and final method. We'll call this example 4. Solve by completing the square. And let's say we have 6x squared minus 48 equals negative 12x. So completing the square is something that we did in Unit 4. And I don't know if y'all remember that one, but that's where we kind of cut the number in half and squared it and added it to both sides. Do y'all remember doing that? Okay, if you don't, hopefully you'll see it when we go through it here. But just to kind of get your mind thinking, just to kind of keep you going with what we're doing, if you wanted to, you could move the negative 12x over, have everything on this side, have a 0 over here, identify your a, b, c, and use the quadratic formula. It always works. If you wanted to use square roots, you cannot because you have a b term here, right? So that wouldn't be an option. We're going to look at another method just to show you another way. I actually like this method. It's a little bit challenging, but we'll take a look at it. So the key with completing the square is you want to isolate your constant. So that means I'm going to move the constant that way and the b term that way, which gives me 6x squared plus 12x equals 48. For completing the square, you have a coefficient on your x squared, a leading coefficient, an a. So we're going to have to factor out a 6. So I'm going to factor out a 6 from this half right here. And so 6 times x squared will make 6x squared. 6 times 2x will make the 12x up here. So now we're there. That 6 is multiplying by the binomial here, so we're going to divide by 6 on both sides, which will cancel these out and give me x squared plus 2x equals 8. So this is where we're going to do the completing the square part. If you remember when we did this in Unit 4, I would say x squared plus 2x, a little bit of space, equals 8. We're going to put a plus sign right here and a plus sign right here. Does that look different than what we did in Unit 4? Yes, it does. Very good. I see some of y'all shaking your head. When we were in Unit 4, we put a plus sign and a minus sign. But here's the deal. I'm going to show you this on Unit 4 here. When we did completing the square in Unit 4, here's that plus sign, here's that minus sign. Your whole equation was on the same side of the equal sign. That's why we did that, because we had to put a plus and a minus to balance it out over on this side. Here, I've got this is on the left of the equal sign and this is on the right of the equal sign. So if I add a number over here, in order for me to keep the balance, I have to add that same number over here. So that's why we're adding on both sides, is because we're dealing with both sides of the equal sign here. So it's a little bit different, but still the same thing. So we're going to take that b term, which is 2. We're going to cut it in half by dividing it by 2. So 2 divided by 2 is 1, and then we're going to square it. 1 squared is 1 times 1, which is still 1. So that means I'm going to add 1 here and add 1 there. We're going to factor this trinomial. So if you remember when we learned that, the shortcut was from your first term, you're going to take the variable, so that's an x. From the second term, you're going to take the operation sign, which is the plus sign. And from the third term, you're going to take the square root of this number. The square root of 1 is 1. So we get x plus 1 squared. And then 8 plus 1 is 9. So now we've kind of taken it from this. Look at what it used to look like. And now it's there. It's actually the exact same equation. We've just changed the way it looks. So we want to get rid of this little 2. So we're going to square root right here and square root to the other side. Whatever you do to one side, you got to do to the other. So this square root is going to get rid of the 2, which will leave x plus 1. And then here's where people are going to forget, even though we just talked about it. The square root of 9 is not 3. It is plus or minus 3. Bring your positive 1 over to isolate your variable. When you bring it over, anytime you have a plus or minus, you want to bring the number over and you want to put it in front. You do not want to put it behind. So that means x is going to equal negative 1 plus or minus 3, which, hear this part, very important, if this was a radical, you would be done. Because it's a whole number, we can actually solve this now. So this is negative 1 plus 3. Negative 1 plus 3 is positive 2, so x equals 2. And negative 1 minus 3. Negative 1 minus 3 is negative 4. So we get those two answers right there. Okay, so that's how you do it with completing the square. Let me try one more just to show you, and then we'll be done. Any questions about that? I'm sorry, I kind of went fast there. Do y'all kind of see what I'm doing there? It's all about organization. It's all about making sure you put things neat. So I don't know if I'm going to be able to fit this in here, but I'm going to try to squeeze it in. Let's say we have x squared plus 6x minus 59 equals 0. Can I use the quadratic formula if I wanted to? Yes. My a would be 1, my b would be 6, my c would be negative 59. Can I use square roots if I wanted to? No, because I have a b term. You can only use square roots when you don't have a b term. So we're going to use completing the square. So first thing I'm going to do is I'm going to bring my negative 59 over. So that's going to give me x squared plus 6x equals positive 59. The nice thing about this one is if you go back to example 4, we had a leading coefficient of 6, so we had to factor that out. Down here, I don't have a leading coefficient, so I'm actually good to go. I don't have to worry about that anymore. So now I'm going to do the completing the square. X squared plus 6x, little bit of space, equals 59. I'm going to add something here, and I'm going to add that same thing here. Whatever I do to one side, I have to do to the other. So for the completing the square, I'm going to take my 6, half of 6, so 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 here and add 9 there. We're going to factor our trinomial. So from the first term, we take the x. From the second term, we take the plus sign. From the third term, we take the square root of 9, which is 3. And we get x plus 3 squared. Equals 68. 59 plus 9 is 68. We want to get rid of that little power of 2, so we're going to square root both sides. The square root of x plus 3 squared is just x plus 3. And the square root of 68 is plus or minus the square root of 68. We're almost done. We want to isolate the variable, so we got to bring this 3 over. And when we bring it over, if you have a plus minus sign, you always put it in front. So x equals positive 3 becomes negative 3 plus or minus the square root of 68. You are actually done. You've got your x isolated. This is the answer. You just have to simplify. You see up here we had 2 whole numbers, so I simplified by just solving it. Down here I have a whole number and a radical, so for me to simplify I have to simplify this radical. So I'm going to go to the side. 68 is 2 times 34, 2 times 17. So those 2's become 2 radical 17. So I end up with x equals negative 3 plus or minus 2 radical 17. And I was able to finish it there. So 3 different methods, 3 different ways to do it. Obviously, if the directions don't tell you which way to solve a question, then the power is yours. When that happens, I tend to lean towards the quadratic formula. It just seems to be a little bit more cut and dry with me. But there are other ways that you can solve. You just have to be careful about what you're doing there.